A mature El Nino is taking control, but the end is in sight. How can we have both at the same time? I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 17th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. To subscribe, just click the Stormsurf icon down in the lower right-hand corner of your screen, and there you'll get signed up and get those automatic notifications. Also, if you'd like to make a contribution, you can. Just hit the special thanks button, the heart with the $sign in it down below. With that, I'd like to thank the folks that donated last week. We start with Our Predicament, Evolution Moto, Tim Caston, Peter Belden, Michael Miner, Jack Harris. Amazing. So many people contributing. It must be Christmas time and folks are feeling generous. We appreciate it. And then we move into the next class of donators. Coach Nate, Ashwin Sandhi, and Rondell. Thank you very much. And then we move to yet a higher tier of contribution. SV Lone Star, very generous. And then even one higher than that, Matt Rapp. Off the chart, a great contribution. Thank you so much. We're going to use all the donations to upgrade our camera for the site, so we'll get a little bit higher definition camera so you can sort of see what's going on better. Now, with that, let's move on to the things that really matter. We'll start by looking at significant wave heights for the North Pacific Ocean. We see remnants of a gale that's been circulating off the central California coast. It is starting to push some weather into the coastal areas, mainly of central and maybe northern California. But this low and its remnants are supposed to move closer as we go in time. We also see a little tiny gale developing off the Kuril Islands with 31-foot seas. But for the moment, a rather placid pattern. But that is to be short-lived. But let's start by taking a look at current conditions. We're looking at the buoys, high-res buoys, Point Reyes Buoy, California. This is seeded buoy, reports every half hour. Buoy 029. We're looking at all the energy that's hitting that buoy from anywhere up at 33.3 second period, very energetic, high-energy waves, which there are none, the whole way down to 5 second period, just pure wind chop. And this graph shows us the height of the energy in each of the period bands, like 14.3 seconds, there's 1 foot of swell energy there. 13.3 seconds, 1.4 feet. You get the idea. And so we see a bump here at about 9 seconds. That looks like wind swell. And then a little bit of energy at 13 seconds, and then a bunch of chop all mixed in. You put all that together, you can tease out the primary and secondary swells. Primary swell, 5 feet at 10 seconds from 233 degrees from the southwest. That puts surf at about head high, and that's about what it actually is. We go look at another seeded buoy down at Point Loma South. This is off of Southern California, San Diego, buoy number 191. Same profile, a little bit of energy at 14 to 13 second periods, a little bit less energy at 9 seconds, and not a whole lot of wind swell. Now remember, the Channel Islands kind of filter out a lot of the junk here, both swell and wind swell alike. Primary swell, 2.8 feet at 13.4 seconds from 267 degrees. That puts surf at about, I call it, waist to chest high, and I think that's about what it is. And then you see a little bit of that southwest swell, 2 feet or wind swell really, 2 feet at 10 seconds starting to work its way in. But the expectation is that'll be coming up while the longer period swell starts fading. And then finally, we make a quick stop over in Oahu, the North Shore, Waimea Bay, buoy number 106. We see a bit of energy at about 11 seconds. For the most part, this is persistent, call it north wind swell from a variety of sources. Primary swell, 5.5 feet at 10.6 seconds from 18 degrees. That puts surf at about a foot overhead. That seems about right, but it's pretty warbly and not really rideable. So let's take a quick look at what's been going on and what has generated swell for the past few days. We had a little gale on Wednesday here in the central Gulf of Alaska, falling southeast with 26-foot seas, fading to about 20 feet and then 18 feet on Thursday. Swell from this system pushed into the California coast on Saturday, also pushed into Hawaii. This gale then started to regenerate, creating this localized gale off of California, but also pushing some sideband energy and wind swell into exposed north and east-facing breaks of the Hawaiian Islands. Seas were up to 28 feet at one point, and now this system is fading out for the most part from a swell production standpoint. That doesn't mean it's not making wind swell, and there's a bunch of south fetch on the south side of this low, going to generate wind swell pushing into California and even up into Oregon. North fetch on this side, creating more northeast sort of wind swell, proto swell, whatever you want to call it, pushing into the Hawaiian Islands. And that gets us to where we are now. But let's go look forward. Things are going to start getting very interesting. We started talking about this last week. We were talking about the jet stream, the strength of the jet stream, and its impact on surf and weather for the southern tier states of the U.S. We're going to start by just showing where we are today. This is jet stream level winds. These winds are up about 30,000 feet, help support the formation of gales when those gales form, help direct their track. We're looking for a trough, a dip into the jet, and that's sort of what's happening here. When you get a dip in the jet, that creates a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure, and of course low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface. They actually impart energy to the ocean and create seas, raw, significant waves. As those waves move away from the fetch area, they get groomed out. The lesser period, the 5, 6, 8 second period energy starts dropping off because it doesn't have a lot of staying power. The longer period swell gets exposed, and of course, when that swell hits your beach, you end up with surf. All right, so we have a little trough up here in the northern Gulf starting, well, right about now. But you notice the jet it's split right at about the date line here. That's classically a sign of a weak jet. But you see back over off Japan, wind is building at, what is that, about 160 knots sort of thing. So sort of keep your eye over here while we're looking at what's going on over here. You see the split jet stream. Anyway, we see there's a little trough trying to get organized in the northern Gulf. Energy dipping south as we get into Monday. Off the U.S. West Coast. Remember, there was already a trough and a low off here. Here we go with another one of those as we get into Tuesday. Fully circulating. Notice winds building to 170 knots over here. The split in the jet starting to ease east a little bit. And then winds start building to 190 knots as we get into Thursday. Still split here. Portions of the trough hanging off the California coast, making for weather. Look at this, 1, 2, 3. That's 210 knot winds in the jet, pushing the whole way from Japan over the date line, starting to fall into yet another trough in the northern Gulf, pushing through the Gulf. Winds still as we get into Saturday at 210 knots. Notice the split in the jet. Gone, at least to this point, a point even east of Hawaii now, pushing towards the U.S. West Coast. That little bit of a split hanging on for California as we get a week from now, Sunday, just poised to come rushing on shore. A flat jet stream with piles of energy running from Japan almost the whole way across the Pacific. And there we are a week out with a big trough forecast in the northern Gulf of Alaska. This is the classic El Nino fueled active phase of the MJO enhanced strong jet stream just ready to come roaring into California. The question is, will it make it? And if it does, when? We'll get into all that. We'll make some wild speculations as we get later in the presentation. The takeaway from this is the El Nino hype, at least for the moment, looks justified because the jet stream is looking, or forecast to look, very good, very supportive of gale and storm development, which theoretically should result in surf and weather, both at the same time. It just depends on where you are. All right, so let's go take a look down at the surface. All up in the high up at the jet stream, that's all good. That's the fuel for storm development, but it takes actual low pressure and wind blowing on the ocean surface to impart energy to the ocean to create surf. So here's our weak little low off the California coast. There's a little bit of south winds at 30 knots making for wind swell. There's your north to northeast winds at 25 knots, pushing swell towards the Hawaiian Islands. We have a new gale trying to get organized here off the Kuril Islands. So we get into Monday. This guy continues to circulate. A new low starts building here in, I'll call it the northwestern Gulf, with 35-knot northwest winds. Broader gale with 40-knot winds off the Kuril Islands, pushing towards the north dateline on Tuesday, continuing with 35 to 40-knot west winds. Local gale off the U.S. West Coast, building with 35-knot northwest winds. So we get into Wednesday, the local gale fades, but still supportive of weather. The Kuril storm pushes over the North Dateline region with 30 to 35-knot west winds, even continuing as we get into Thursday. And remember, this is not with the Jetstream really in its, prime setup. This is just sort of a warm-up to the main event. As we get into Thursday, here comes another gale building, pushing through the Gulf, enhanced by the jet stream with 45-knot, we'll say northwest winds, pushing just flat through the Gulf, following the jet stream on Friday, likely pushing energy towards Hawaii, but more towards the U.S. West Coast. Notice another one right behind it as we get into Friday night with 40-knot winds. We get into Saturday, the first gale starts fading out. He's more like a primer gale, if anything. He's just clearing the way. Here comes a stronger event, 55, maybe 60-knot winds in this one, approaching hurricane force, aiming fetch a little bit at the Hawaiian Islands, but mainly at the U.S. West Coast. So we get into Saturday, and still even Saturday evening, 55-knot winds. So we get into Sunday. Here we go. Big gale in the Gulf of Alaska with 45 to almost 50-knot winds. Notice just a little slither of reasonable weather holding off California. And then it looks like another system trying to build right behind that as we get into Monday, on Christmas, the 25th of December. So an interesting little pattern setting up. But again, it's not the jet stream. It's not even the winds at the ocean surface. What do those winds do to the ocean surface? That's what really matters. Well, we have seas here off California, but they're weak, and what is this, maybe 14 or 15 foot, so not really a swell producer. We start with the gale, first off the Kuril Islands, 30-foot seas, building to 32 feet as we get into Monday night, then going into about the 28-foot range on Tuesday, pushing over the North Dateline region, still with, 25 foot seas in the northwestern Gulf of Alaska on Thursday. Good for producing swell, aimed at mainly the Hawaiian Islands and the U.S. West Coast. But we know, or at least we suspect, something better coming behind that. First up, the first little gale, 28-foot seas on Thursday night, building to 33 feet right there, 33.5 feet. The highest seas over this entire domain. See the little plus sign there? There's the plus sign there. So we know we're looking at the same position. Then fading to about the 29 to 30-foot range as we get into Friday night. And Saturday just plowing right through the Gulf with another system right behind it. So we get into Saturday morning with 36-foot seas, quickly building to 43 feet. By Saturday late afternoon, 46.7 foot seas. This is again one of those super long period death energy swells. Still pretty much to the north though, so not so great for Southern California. It's going to be a lot of this is going to be shadowed by the Channel Islands. The brunt of the activity is going to be from Point Conception northward. Certainly swell for the Hawaiian Islands as well. And notice and remember, the models tend to, or at least lately, have been undercalling the early forerunner swells from these really energetic high sea things. So embedded in this thing, I'll forecast it, whatever, or accept the fact that there could be significantly higher long period waves on the front end of whatever swell results. So we get into Sunday, the system starts fading with seas from 40 feet. And we're a week out. By a week from now, Sunday night, that gale still with 32-foot seas over a very broad area in close proximity to the California coast. See the leading edge of the swell front approaching the Hawaiian Islands, and our next gale starts building behind that with about 26-foot seas. So a pretty energetic ocean pattern setting up. Let's go look at the local wind forecast. We're California here. There's San Francisco, Point Conception down there. Southern California here. You see this southeast wind pattern at about 10 knots for the California coast today. Trades that kind of dreaded northeast 15-knot trade thing for the Hawaiian Islands. Let's get into Monday. South winds, 20 knots, California coast. Trades still maybe east-northeast at 15 knots. Maybe things cleaning up just a little bit for the Hawaiian Islands. So we get into Tuesday. The front blows through. In fact, we can go back. You can kind of see a front right along there. Blowing through southwest winds for the California coast north of Point Conception. And east-northeast trades at 15 to 20 knots for the Hawaiian Islands. Here's our new gale, winding up off the coast on Tuesday. Again, here comes the south winds Tuesday night into Wednesday for California. And finally, maybe still east-northeast, 25 knots for the Hawaiian Islands, but on the strong side. Thursday, winds go offshore from, we'll say, maybe Big Sur northward. Strong trades driven by high pressure for the Hawaiian Islands at 20 knots. So we get into Friday. Here comes the same high pressure that's been driving the onshore flow for Hawaii, starting to generate northwest winds for the California coast. Trades due out of the east, 15 knots. Things finally cleaning up for the Hawaiian Islands. Saturday, just pretty much a blown-out mess from Point Conception northward with high pressure. And lighter trades, 15 knots for the Hawaiian Islands. We get into Sunday. Finally, things lighten up for California. Let's see, we got one more frame there. There we go. And even one more. Yeah, light wind regime by Sunday night for the California coast. Trades light for the Hawaiian Islands. Pretty nice setup. Big front, though, just lined up right along here, making it to Cape Mendocino on, we'll say, very early Christmas morning. And then a rainfall forecast for California. And the question is, where is the rain? Where's the snow? Well, up here, at least in the San Francisco Bay Area, we had some rain. Not a whole lot, but we had kind of off and on moderate showers for the Bay Area, even pretty well inland. As we get into Monday, it looks like that pattern continuing, if not building even stronger. But notice nothing up into the Sierra yet. There we go as we get into about 10 a.m. on Monday. But this is very high elevation snow, probably, I'm going to guess, just 10,000 feet or higher. So most ski resorts probably are only going to be seeing rain, except very, very close to the top. So we get into Tuesday, pretty much the same deal, same snow configuration, but it looks like colder air might start trickling in as we get into midday Tuesday. Heavy snow for higher elevations of the Sierra, focused on, well, there's Tahoe down to about Mammoth sort of thing. So that's good news for those resorts. Wednesday, things back off. It looks like a mixture of rain all along the coast again. And then finally on Thursday, the dry out starts going from north to south. It won't be till later Thursday, maybe even not for, oh, look at that. You can see that looks like snow. I'll call that for Mount Whitney in that area. Mammoth, maybe. Probably, again, only at high elevations. Notice rain into Southern California. In fact, for Southern California, let's wind this back real quick. You can see light showers starting, we'll say Tuesday afternoon. But here's the bulk of the rain coming in on Thursday for Southern California into first thing Friday and even pretty much through the day Friday. So a little bit of rain for everybody, not near enough what we need, but at least a taste and some snow up high. And then you see the next system winding up as we get into Sunday, a week out. Whether it will make into California, well, we'll have to wait and see on that. I mean, looking at the models even a week out is a bit of a folly, but, we're hopeful. All right, the snow forecast dashboard for Palisades, Tahoe. According to this, right at about 22 inches for the first event, all this being on the 19th, so what's that, Tuesday or so? Yeah, Tuesday. And then theoretically, another bit as we get just past Christmas, day after Christmas, getting us up to a total of maybe 44 inches. I'm not going to believe that. Now, here's the key. This is the freeze level line, okay? Red is liquid precipitation, gray is sleet. Right at the intersection of gray and white is the 32-degree freeze line. Okay, this is the base of Palisades, Tahoe. This is the summit up at about 8,900 or 9,000 feet up the top of Palisades. You can see the snow line right at about 8,500 feet, theoretically dipping down to maybe 7,000 feet. That's actually better than what it was the previous run of the model. And then generally hanging in about the 8,500 foot range the whole way through Christmas, and then getting a bit deeper with snow the whole way down to the base. That would be about, right here's about 5,800 feet for the second snow event. Let's go check some other resorts. Sugar Bowl, maybe a little bit more, 25 inches, and then getting up to about maybe 49 inches. The reality is it's only all of, as the crow flies, you can almost see it from the top of Palisades, Tahoe, maybe 5 or 8 miles different, something like that. Coming down to Kirkwood, south of Lake Tahoe, with about 18 inches, and with the second event, maybe 34 inches. And then we get down to Mammoth at, we'll call that, about 18 inches or so, and then pushing up to 24 inches, 2 feet with the second event. So a little bit of snow for everybody, not as much as we want. Really want to see like a 60-inch dumper, but that's not happening in the next week or two. So a quick look, surf, what is going to happen? We'll start in Northern California, Ocean Beach. We see some sort of like 5 to 6 foot type surf, but when you see these dropouts, that means a bunch of wind swell. This would be on Monday and Tuesday. No big surprise. It's all like south wind swell. Then we see a little push of swell from the gale pushing through the Gulf, theoretically up to maybe 10 foot as we get into Wednesday, dropping off on Thursday, and then we're into a wind event of some sort on Friday, and then we see potentially more swell in the 9 to 10 foot range as we get out into Sunday sort of thing. Looking at swell heights, well, here you go. We see 5 feet at 10 seconds, 10, 11 seconds, all wind swell basically. Wednesday we get our pulse of 7.5 feet at 13 seconds. Things dropping off from there. Then as we get into the weekend, we see, what do we have? A little bit of wind swell, and then 6 to 7 feet in the 15-second range and fading some from there. Then we go down to Santa Barbara. We see surf in the 4 foot range. This is all wind swell, southwesterly wind swell sort of thing. Fading off as we get into Monday, Tuesday. Wednesday, the new swell comes in. Surf in the 3 foot range at top, that fading off. And then whatever swell's coming on Sunday, looks like it's all shattered because really nothing going on there. Looking at swell heights, we see the wind swell thing going on here. 3.5 feet at 11 seconds on Monday. Fading from there, the next swell coming in late Wednesday, if not Thursday, 2.5 feet at 13 seconds and fading. And then whatever happens out beyond there, it looks like it doesn't even reach inside the Channel Islands. Then the North Shore of Oahu looks like a wind swell mesh. You can just look at the trade wind numbers here, 25, 26 knots out of the east-northeast. Not conducive really to surf. Things back off a little bit. We do see surf heights in the 8 foot range as we get into Friday. That's likely swell from the Kurill Islands working its way in and fading from there. Let's go take a look at swell profile. 7 feet at 11 seconds. There is some real swell mixed in, theoretically 4 feet at 15 seconds. I think the wind is going to be a bit of an issue. And this is all swell from the gale off the California coast, continuing into Wednesday, but I think the real issue is going to be wind. And then we see the Kurill Island swell showing 5.5 feet at 15 to 16 seconds on Friday, fading out from there, and maybe another little pulse of 14 second energy, 4.5 feet as we get into Sunday. So, swell for the Hawaiian Islands, the real factor is wind. All right, let's go take a look long term. What's going on with the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation? These two oscillations are the major influencers of weather production in the Pacific Basin. We start by discussing the MJO, the Madden-Julian Oscillation, this periodic weather oscillation that has two phases, the active phase and the inactive phase. The active phase is a low-pressure system, the inactive phase a high-pressure system. They are diametrically opposed, one on one side of the planet, one on the other. They rotate from east to west around the planet on the equator. So one here, the other here, rotating around the planet on the equator like that. The active phase being a low-pressure system, it takes warm, moist air down at the ocean surface, sucks it high up into the atmosphere, gets caught by the jet stream, it energizes the jet stream, and fuels storm development. Also, when in the far west Pacific, the active phase dampened trade winds, allowing warm water that's normally there to start sloshing to the east. If you have successive active phases of the MJO, they create what's known as a Kelvin wave, that ball of warm water that's set up when warm water by the active phase starts sloshing from east to west under the equator due to the decrease in trade winds. We are now on Kelvin wave number 8, pushing into the East Pacific. It takes the balance of warm water that's normally pulled up in the West Pacific and pushes it to the east. When you have these successive active phases and successive Kelvin waves, that ushers in El Nino. If you've been following this video, as most of you have for the past year or more, you know that it's been a train of Kelvin waves and all that are supporting what we think is now reaching close to the peak of El Nino in the ocean, but that does not mean El Nino is peaking in the atmosphere yet. We think, in fact, it's just getting started. You got to move all that warm water from the far west Pacific to the east. It has to sit there for months and months. Then it starts evaporating and starts changing the jet stream. The ocean is a big boat. It takes a long time to turn. So only now is the atmosphere, with the change in seasons, starting to change in favor of an El Nino pattern. You saw the jet stream model. It's getting ready to start to roar right around Christmas time. That is classic El Nino setup, and all driven by this Kelvin wave jet stream connection. They call it a teleconnection between the ocean and the atmosphere. So that's where we're at. That is starting. And as we start looking at some of the other signs in the atmosphere, and some of you have even made comments on the video about some discouraging news in the far west Pacific, but not to worry. I mean, if things are starting to decay in the west, it will be 6 months before it really manifests itself in the jet stream. So we've got months and months to go with plenty of energy injected into the atmosphere to support storm development. All right, so let's start by looking at winds on the equator. We're looking for signs of the active phase of the MJO. This is data from the TAO buoy array, a series of buoys strung from west to east across the equator used for monitoring El Nino. They have wind sensors on them. See the arrows? These are 5-day average winds. So we're looking at winds in the East Pacific, out of the east, pretty strong. Just look at the length of the arrow. Also pretty strong in the Central Pacific. There's your date line right there. This is the equator right here. Winds strong, but notice there's a little bit of some westerly thing going on here. Also notice water temperatures, 30, 31, 32 degrees, maybe even 33 degree centigrade, way above normal in this pocket here, just a bit east of the date line. It's not actual wind speeds that matter, though. It's the anomalies, the difference from normal for this time of year. If the winds are weaker than normal, especially over here in the far west Pacific, that is what sets up a Kelvin wave. So we're looking at the arrows. Normal winds, even though they're strong out of the east, that's normal for this time of the year. In the East Pacific, in the Central Pacific, but when we get here in what's known as the Kelvin wave generation area from 170 west, the whole way as far west in the Pacific as you can get, look at the arrows. They're out of the west. That looks like the active phase of the MJO, and that is a good sign. So let's go look at the forecast for the next 2 weeks from the GFS model. This is the east-west component of the wind. We're looking for westerly anomalies. That would be the reds and the yellows. But remember, this is the whole planet. The date line runs right up the middle. So the far west Pacific starts about 120 east, or 125 east, so right about there. All right, looking back, and Kelvin wave and generation area ends about 170 west right here. So this is the area that, one, if you have west anomalies, it can create a Kelvin wave, assuming there's warm water present. And two, if you get westerly anomalies, it injects energy up into the jet stream. Good news is we see westerly anomalies. We had a big Kelvin wave back here in, we'll call it mid-November. Then we had and the active phase of the MJO, things kind of have been moderating since then. You see this persistence of easterly anomalies, inactive phase of the MJO. Then starting about December 7th, the first little signs of the active phase building. Here we go. Strong westerly anomalies forecast on the date lane through about the 26th or 27th of December sort of thing. So another active phase of the MJO looks likely, and then easterly anomalies set up after that, maybe the inactive phase. So this looks like a big target for one, imparting energy to the jet streams, and we already have looked at the jet stream models. It looks like they're going to roar. This is doing the magic it's supposed to do. What happens after that is a bit of a question. So let's dig a little deeper. We're going to look at outgoing long-wave radiation, cloud cover. If the active phase of the MJO is a low-pressure system, and of course low-pressure systems feed energy to the jet stream, they also take warm, moist air, lift it aloft, it hits cold air up there, turns into clouds. This is a model of just cloud cover. The blues, cloudier than normal skies, less sunlight reflecting off the ocean surface. The equator's right here, South America, Central America, Hawaii, New Guinea there. Date line right there. Kelvin wave generation area, the area we're interested in, right there. This is suggesting the active phase of the MJO is in control, supposed to remain in control through day 5 of the model run, maybe even hanging on to day 10, and then a weak inactive phase sets up 2 weeks from now. So that'd be getting into the new year or even a bit later than that. But that is a statistic model. The dynamic model, the GEFS model, suggests active phase holding on in the Kelvin wave generation area, maybe till about 9 days from now. Then the inactive phase sets up building, likely cutting the legs somewhat out of the storm machine as we get into 2 weeks from now. Digging in a little deeper, these are the phase diagrams for those same two models. Statistic model here, dynamic model here. How do you read these things? Well, first, we know that the active phase of the MJO moves from west to east, from the Indian Ocean over the maritime continent to the West Pacific, to the East Pacific, underneath the United States, across the Atlantic, over Africa, back to the Indian Ocean. And you can see where the active phase has been in November and then here December. The heavy dot is where the active phase is right now, so in the West Pacific, and pretty weak for the moment. Forecast over the next 2 weeks to move to the Indian Ocean, and very weak. The further the dot is away from the circle, the stronger the active phase is, so a very weak active phase. The dynamic model, pretty much painting the same picture, but with the active phase maybe a little bit stronger over in the Indian Ocean 2 weeks from now. Here's another statistic model showing upper level moisture, 200 millibars, so jet stream level moisture. The greens, wet air. The oranges and yellows, dry air. South America, Central America, New Guinea, equator right there, date line roughly right there. Wet air means the active phase of the MJO. So active phase of the MJO over the Kelvin wave generation area, pretty much fading out after the day after Christmas, 26. Here comes our inactive phase of the MJO, making its transit across the Pacific somewhere into about the 15th of January. So that's only a 2-week-long window. And then here comes the active phase again, latter half of January into the end of January. So a little bit of an MJO pattern indicated. But let's get back to those east-west anomaly things. The reds, west anomalies, the active phase of the MJO, the blues, east anomalies. Now this is the whole planet again on one chart. Dateline runs right up the middle here. Okay, this is past performance. Oh, and notice the heavy black line, MJO. A dotted contour means inactive phase, solid contour, active phase. So you can see the relationship. Blue, easterly anomalies with the inactive phase. This was back in Halloween time, early November. Active phase in middle November to almost late November with strong westerly anomalies. Right now, we're going through or have just been through the inactive phase of the MJO with a mixture of blues and oranges, so kind of a neutral pattern. Here we go, boom, right back to active phase of the MJO, strong westerly wind pattern, feeding energy into the jet stream. maybe building another Kelvin wave. I don't know if there's much warm water left over in the far West Pacific. And West Anomalies forecast on the dateline holding till mid-January. Now, here's the other thing. These are easterly anomalies here. This is a part of what they call the Indian Ocean dipole, the positive phase of it. We're not going to get into all that, but the short is right here. So that's in the far West Pacific. The indication is if you have west anomalies here and east anomalies there, so you must have downward falling air that hits the ocean surface and then splits in two directions. And you can see that here, west, east. This is the downward branch of the Walker circulation. We think there's an upward branch somewhere over in here. We'll get into that in a minute. But this is, again, you want the upward sucking branch of the Walker circulation somewhere near the date line between there and Hawaii. That's feeding moist, warm air aloft. That hits the jet stream. That feeds the storm track over the North Pacific. And then you want your downward branch of the Walker circulation, the one over in the west, falling somewhere over, which is happening right here, right on the hairy edge of the far West Pacific. Now notice, the easterly anomalies start creeping into half of the Kelvin wave generation area as we get into January. And that limits the area for westerly anomalies. This is pretty much a classic El Nino kind of pattern. It just means El Nino, probably right about now, right here, is fully mature in terms of a building strength perspective, in terms of Kelvin wave production, in terms of moving warm water from the West Pacific to the east. This is probably the last of any of that Kelvin wave thing that we're going to get. Now, just because this happens doesn't mean, well, it's all dead. Again, momentum in the atmosphere. There's still piles of, we'll get into this in a minute. This is the production of a Kelvin wave. It takes 3 to 4 months for the Kelvin wave to make it across the Pacific, and then to erupt off of Ecuador, and then to start feeding energy up into the jet stream and continuing to reconfigure the jet stream pattern and the Walker circulation over the Pacific. So we're probably at the mature phase, and actually sometimes this happens as early as Thanksgiving. To have it happen around Christmas time is pretty normal, and this is pretty much just the standard template for El Nino development. Nothing to be concerned about. What I'm more concerned with, in a good way, is outgoing long-wave radiation, the buildup of cloud cover over the dateline, signaling the change in the Walker circulation and the digging in, or the maturity of El Nino and its grasp on the atmosphere and feeding energy into the jet stream. So a year ago, let's look at this chart. So the oranges and reds are dry air, the blues are wet air, and the dateline runs right up the middle here. Okay, so and this is last year. And the far West Pacific, right about in there. So last year, dry air over the dateline, wet air over the maritime continent, classic La Nina setup. We go through a transition come July. You see wet air that was here starts migrating over the dateline, building, and building even more as we get to where we are today, where we have massive dry air over the maritime continent. So we go from La Nina to El Nino, and that's where we sit right now. Let's go look at the forecast. So this is outgoing long-wave radiation. What's happened is down here, the forecast is up here. There's today's date. The date line running right up the middle. The blues meaning more cloud cover, more clouds, more moisture. The date line right there. You see this slowly building wet pattern that's been going on, pulsing in November, pulsing again in December. Here we go. And the forecast, with it just hanging right on the dateline the whole way through mid-March. Classic El Nino pattern, while dry air over the maritime continent here. And that pattern holding, though maybe getting a little bit weaker as we get into March. And also notice, and I don't know if I can do this correctly, but the wet air pattern, there's the dateline right there. So it was even west of the dateline at one point, making it to the dateline somewhere in November, and then moving east of the dateline as we get into March, finally with it being, and this is really hard to do, right there about 150, so about north of Hawaii. Again, a classic shift in the Walker circulation to the east, bringing the center of storm production certainly closer to Hawaii and certainly closer to the U.S. West Coast, California at 120 west. This only helps fuel pushing storms into the U.S. West Coast and hopefully further to the south and not to the north. Then we play this same game looking at the east-west component of the wind, westerly anomalies, right? Okay, here is your big easterly pattern that was over the maritime continent. Here's your building 1, 2, 3, multiple just westerly wind events. Here is our next one developing right now, peaking right at Christmas, right? Actually, a little bit to the east of the dateline, and then you see continued westerly anomalies on the dateline. Again, this is like classic El Nino, and then moving off to a point, I'm just going to roughly say about 150 west north of Hawaii as we get into March. So, not to be concerned, there is continued support for jet stream enhancement. And that flat jet stream thing that we were looking at on the models, we expect to see more of that in pulses as we go the whole way through March, feeding storm development, with the center of storm development moving maybe more from the dateline and more towards the, I'll say, the northwestern Gulf of Alaska over time. Let's overlay the MJO here. Okay, so here's our current active phase of the MJO, just now getting its toe fully in the door in the Pacific, expected to hold the whole way into about January 10th and then fading out. And then after that, a pure neutral pattern setting up. Interesting, because the model was suggesting kind of an alternating active-inactive pattern, but during real El Niños, you pretty much see the MJO disappear, which this is suggesting, at least for the moment. Now let's overlay the low-pass filter. This is your high-pressure, low-pressure bias. Dotted contour, high pressure, La Nina. Smack over the maritime continent, as one would expect, with 1, 2, 3, 4 contours of low-pressure bias sitting. Now notice, back in August, it was right on the dateline. But then as we got into November, it moved to about 170 west, just a little bit, 600 miles, let's say, east of the dateline. Forecast holding somewhere in there into February, and maybe not even moving a whole lot. We'll put it right there. Where's that get us to? Let's say maybe 160 west as we get into March. So a well-established low-pressure El Nino signal, and with the leading edge of this, now notice this, California starts at about 122 west, right? The leading edge of the low pressure bias over California and pushing further into the U.S. West Coast as we get into March. That would be roughly, 100 west. I don't even know where that is. That's somewhere like Mississippi or something, I'm guessing. Colorado, maybe. So plenty of low pressure bias down on the equator to support the jet stream pushing into the southern tier states and bringing moisture into Texas, Colorado, New Mexico, Arizona, you name it, as we get through winter into March. So it looks like a pretty good El Nino fueled pattern is setting up for winter along the southern tier states. Hooray. All right, so what's going on in the ocean are these Kelvin waves that we've been talking about. Can we actually see that? And of course the answer is yes. All right, so this is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. These X's, as you know, are the anchor lines on the buoys. The X's are sensors strung down the anchor lines. They collect water temperature data, and then you use a model to fill in the gaps. 30 degrees centigrade. That's really warm water. It's actually backtracked a little bit the past couple of days. I think it was at 163 or 162 last week. It's backtracked a little. 29 degree isotherm backtracked about 2 degrees as well. The 28 degree isotherm, I think it was at 140 last week. It's gone back maybe a degree or, not very much. The 24-degree isotherm, if anything, has gotten a little deeper, suggesting more warm water building over here in the far East Pacific. But we don't need to guess. We can look. Actual anomalies, difference from normal for this time of year. All right, the thing that gets your eye here, 4, 5, maybe 6 degree above normal water here off of Ecuador. Massive Kelvin wave. Now, there was one lobe here and one lobe here maybe 2 weeks ago. This was Kelvin wave number 7/8. It is merging all in to make this one big pool now. It's pretty much effectively done that merge. The last little bit of it is hanging here at, what is that? About 165 west. There's still warm water coming off the maritime continent, but also notice 2 degree negative anomalies. Now, really, it's only about 150 meters down that we're interested, but there's some sense here that maybe the warm pool is getting tapped out here. I mean, because 8 Kelvin waves is a lot of warm water to push off, and eventually cold water at depth just kind of takes over. And that is the beginning of the pattern switch, but it isn't going to happen in a week, a day, or a month, or even 6 months. It'll be, probably not till next fall that we really see a change. Remember, the jet stream has been building towards where we're at right now since about this time last year, right? Even in November, I think, was the first Kelvin wave that came across the Pacific. So we've been playing this game, building momentum towards the peak of El Nino for a year now. The El Nino we have is not going to die in a week or 2 or a month. It's going to take probably not till next year at this time till it's all wiped out from the atmosphere. So for right now, a very healthy pattern. Looking at data derived from a different way, from a satellite, it's not looking at actual water temperatures, but again, we're going down 100, 150, 200 meters down the ocean. There's your cool pool. There's the last of the warm water trickling off the maritime continent. There's the tail end of our Kelvin wave number 8 here, at 170 east. And here's the bulk of our warm water with the leading edge of Kelvin wave 8 pretty much pushing up into Ecuador, erupting. I don't think it's actually erupting. It's erupting, I think, from the Galapagos out to about somewhere around in here, maybe 110 west, maybe even as far as 120 west, so south of California. Hard to tell, but we think it will become evident, more evident on the surface than it is at the moment. There's still... Yeah, we could have a debate about how much warm water's left here. 2 months worth, maybe 2.5 months. That would get us into, well, we're December to January to mid-February, something like that, before then this cold water pattern probably starts building in behind. So, I mean, we got plenty of warm water to get us through the peak of this El Nino. So, but you can see the end is poised. Pentad sea level anomalies as of December 9th. This is the satellite data that I was talking about, used to build the previous chart. You take a satellite, you measure the height of the sphere of the ocean, take out the waves, wind waves, the tides, and is the sphere higher or lower than normal? If the sphere is higher, then it means that if you have warm water at depth, it expands, it'll displace the water above it and create a bump on the ocean surface. So there's Chile, there's Peru, Ecuador right there. The Galapagos is the equator. This is the date line here. Hawaii's up there. You see this big bolus of positive anomalies, 5, 10 centimeters. Means there's lots of warm water from the date line the whole way into Ecuador. Months of warm water still pushing off to the east, erupting. Well, California, let's see if we can get that right about there. I think the eruption point is somewhere between the Galapagos and California, so somewhere out here. It's not making it the whole way into Ecuador, but lots of warm water erupting. It'll all make it to the surface and continue to fuel this displacement of the jet stream to the east, pushing into California as we go through the winter months. Exactly what you would expect during El Nino. Here's the upper ocean heat anomalies graphed out. West Pacific here, East Pacific here. You go back a year, this is December of last year. Cold water in the east, all the warm water balled up in the west, driven by stronger than normal trades, driven by high pressure over the Pacific. Then we get into, well, you can see it up here back in, I guess it was December. One little weak Kelvin wave barely made it across the Pacific, cut the legs out of the cold water flow. Kelvin wave number 2 in January. Kelvin wave number 3 in March, all driven by the active phase of the MGO. Kelvin wave number 4 in April. Kelvin wave number 5 in May. Kelvin wave number 6 in July. Kelvin waves 7 and 8. There's actually 2 of them here. One there in October and November. And you see we have as much warm water here right now in flight as we've had at any point in time prior. So piles of warm water still developing, but you see the cold water that was here during La Nina starting to develop here. It too will act like a negative Kelvin wave, make its way across the Pacific at some time once the MJO and westerly anomalies shut down. Probably we'll give it a couple more months. All right, what's going on at the ocean surface? That's what really matters. Warm water on the ocean surface evaporating, which then drags the jet stream with it to the east. Well, so here's Chile, Peru, Ecuador, the Galapagos, Central America, Hawaii out there. The equator right about there. Warm water, piles of it, all lined up on the equator, the whole way out to the dateline and beyond. The key point today, hey, a little bit of a tiny little pocket of warming. You've seen the warm charts. Maybe next week we'll show it to put this in historical perspective, but this doesn't compare to 2015. This does not compare to 1997 or to 1983, but still stronger than any other El Nino, other than those, 3 super El Nino events. This is a strong El Nino. Now, the past week, there's a little concern because temperatures out here and out here don't look as warm as they did a week ago or even the week before that. We think some of that is because the inactive phase of the MJO has been passing over this area, creating easterly anomalies, creating some mixing. But we know there's warm water down below underneath all this, and it's starting to push to the surface. So I expect some rebound out in here in this whole area as the next Kelvin wave starts erupting. Sea surface temperature trend for the past 7 days. Well, we did see a finger of cooling here last week and the week before. That's all gone. Warming starting, again, basically saying we think the inactive phase of the MJO is gone past this area, and we're back to sort of just a normal pattern, warming off of Chile and Peru, but no wholesale massive Kelvin wave eruption. But this is a 7-day trend. The waters are very warm here already, so it would take a whole lot of warming to get some big red thing to light up here. So we don't expect more than seeing maybe little momentary pockets for a couple of days of stuff out in here over the next couple of weeks. And then finally, the full view. There's your concentrated warming right there south of, there's Baja in Mexico. And the trades will eventually drag this out over here and backfill in some of this, we think, but some of the models suggest maybe a different pattern. So I'm not going to get myself too caught up in, this all has to be dark red and, and it has to be 2 degrees above normal and all that, because that's asking for a super El Nino. And the models have not said this was going to be a super El Nino. They've said it was going to be a strong El Nino. 2 weeks ago, we kind of hinted that, maybe we're going to get very close. And as soon as we said that, like 3 days later, all this started cooling down out here. That said, I think there's still more warming to come, but that is more a minority opinion as compared to what the models say. I'm going to be real interested to see what happens with the consensus model. I think it comes out in 3 days or so. So we'll get a we tend to follow one model, but then once a month we get to go look at all the models and see what they say and sort of try to average them all out and see what's going to happen. So that we're waiting with bated breath for the 20th of December to see the consensus model. Sea surface temperatures in the Nino 1.2 region, the area right there by Ecuador and the Galapagos. You can see sort of a steady downward trend. Waters are not as warm as they were along Ecuador. The warming, the place where the Kelvin waves erupted, again, I've been saying they kind of seem to be focused more west of the Galapagos now. The trend suggesting that today's value, 824 thousandths of a degree above normal. We were up at 2.2 degrees, and I think at one point we're even at 3 degrees or higher. So a downward trend here, but this isn't the one that matters. It is the Nino 3.4 region, the official El Nino region, the region on the equator, 5 degrees north and south of the equator, from California out to almost the dateline. The trend today, plus 1.457 degrees above normal. Now, this is the CDAS index. It is not the official index. This actually reads low. We'll go look at official temperatures here in a second. But you see, in general, since November, the trend for the most part has been up or stable. Temperatures in this region, 0 to half a degree below or above normal are neutral. Half a degree to 1 degree above neutral is considered for 3 consecutive months, or for, it depends on how you read it, but I'll just say 3 consecutive months. That's considered weak El Nino. Moderate is 1 to 1.5 degrees. We know that all this is up here in this 1.5 to 2 degree range, which is strong El Nino. Super El Nino is above 2 degrees. We don't really expect that's going to happen. We're hoping to flirt with it, but that's about as close as we're going to get. Equatorial sea surface temperature anomaly history. West Pacific here, East Pacific here. Going back a year, there's your cold water all over the equator in the East Pacific La Nina. And then you can see the effects of the Kelvin waves with the building warm water pattern that started in, we'll say, mid-March and built and built and built. And then you see the warmest waters pulling away from Ecuador to almost 100 west today. There is probably your peak, just one little area of warming in September. But then you see the actual aerial coverage. What is this? Let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 2 degrees or above. This would be your super El Nino configuration. And 2 weeks ago, I go, it looks like we're really close, but then you see we lost, and we're back into the 1.5 to 2 degree range as of right now. The question is, are we going to get some more warm bubbles showing up, and is this branch going to rebuild? I think it could possibly for a week or two here in the next 2 weeks, somewhere before the end of January, but after that, then I'd say we're probably peaked out. And then it's more just sort of maintenance mode, trying to maintain 1.5 degrees or above in this area. Here are the official weekly readings right here for the Nino 3.4 region, actual temperatures and the anomaly difference from normal. So back in September, even go back to August 30th. August 23rd. This is where we started in strong La Nina territory, strong El Nino territory. So August to September to October to November. That's 3 months, 3 consecutive months already at strong El Nino stats. We were up to 2.1 degrees, moving into super El Nino territory the end of November. But then this last week was December 6th. We dropped a bit. We'll see what happens on the next weekly reading. I think it comes out in a day or two. But my guess is it'll probably bob out somewhere about 1.8 or 1.9, something like that, and just put us firmly in strong El Nino territory. Let's keep digging. Ocean currents. So last week, here's the equator right there. That's New Guinea there. Our westerly current, it just kind of dies somewhere. Where is that? That is at 157 east. 2 weeks ago, it was raging like way over to here. This is the effects again of the inactive phase of the MJO, but we know the active phase is building again, so we expect to see this current build back some. You also see the easterly current pushing from, there's Ecuador there, the whole way out. Now that paints one picture. Let's go look at, let's see if we can do this here, sea surface temperature anomalies. All right. So you can see your much warmer than normal temperatures all in here, and I can pick some of this out and just do that's 3 degrees above normal, 3.2, 3.6, 2.9. I'm just randomly 2.2, 2.8, 2.8. 2.8. Okay, and you go, that's all super El Nino. Yeah, but you go to 5 degrees north and south, so you go down in here, and these are 1.7s, 1.7, 1.7. So it's an average of all this from, where's 120? Yeah, that's 120. So this area from here down to here out to, is this, 170 west. So all that right in there is what makes up the official record. And you got to deal with the colder pockets here at 1.5, 1.7, all that sort of thing. So you average it all together. Still, very warm temperatures. Now let's go do one other thing. Let's not look at these sea surface temperature anomalies, but the actual sea surface temperatures. And here you go. A big warm blob of much warmer than normal water being driven to the east by westerly anomalies, the leading edge of it now south of Kauai, and it's continuing to push off to the east. That will backfill into that is, in fact, already in the Nino 3.4 region. The Nino 3.4 region ends right there. So and it goes from here to, I don't know where 120 is, right about, right there. So it's this box from here to here to here, and the really warm water is just starting to move into it. We assume it's going to continue moving to the east, and we know there's upwelling occurring out here from the next Kelvin wave, so plenty of potential to keep warm water in the Nino 3.4 region. But let's dig a little more. What does the atmosphere think is going on? We look at the Southern Oscillation Index. Difference pressure between Darwin, Australia over the Indian Ocean, Tahiti, and the Pacific Ocean. When pressure is lower in Tahiti, as one would expect it to be during El Nino, your index should be negative. Well, it's not at 7.42 plus. It's been pretty much positive for a few days now. Going back over the past months, it hasn't really been solidly negative for a month now, which is a little bit perplexing if we're in El Nino, and I can't explain it, and I don't know what's going on. The 30-day average, so this is the daily stuff. This would show your pulses of active and inactive phase of the MJO. Active phase driving this negative. We're at minus 1.79. We were down at minus 9. I said at some point we should be down at minus 25. That's it during a super El Nino, but we're nowhere near that now. The 90-day average, which is your El Nino indicator, says minus 6.95. You can see it was actually down at minus 11 a month ago. So this is suggesting, if anything, darn near neutral. Let's go look at a graph of this. So here's your 30-day moving SOI graphed out. There's the neutral line there. We're going back to January 2021. Kind of these are the inactive phases of the MJO, the upward spikes, the downward spikes of the active phase. During La Nina, the inactive phases take over. You can see our index was as high as it could be, up at 25. Massive, multiple active phases set up in June, well, from January to June, put us down right where I thought we'd be. And then we lost it in July. We've kind of been toggling around somewhere in, I'll call it minimal El Nino status from a Southern Oscillation Index perspective. So I can't really understand what's going on here, and I keep saying, well, the active phase is coming and it'll push it negative, but at this point, I don't think that's really going to happen, and I can't explain it. I don't have an answer. Here is the forecast for sea surface temperatures in the Nino 3.4 region from the CFS version 2 model, one of 20 models. It says temperatures peaked out in November and are supposed to hold till about right now at between 1.9 and 2 degrees above normal. And then as we get, this is mid-January, they fall to 1.6 degrees, maybe 1.65, which is still strong El Nino status. And from there, then we start the decline. Notice sea surface temperatures are still in El Nino category into May. All right. That's 5 months from now. So yes, they're declining, but the atmosphere still sees the warm temperatures, still is adjusting its jet stream accordingly. We'll be long past winter and spring before we even hit neutral territory, but it looks like we're heading for La Nina as we get into next fall. That said, even if we're down here in La Nina territory, again, the atmosphere is a big boat. The jet stream will not be changing on a dime. It's probably a 3-month lag. Go back 3 months and we'll be neutral, but there'll still be piles of El Nino enhanced moisture in the jet. I would think as we are into, and much as what happens in the transition from El Nino to La Nina, the fall and winter during that transition, you get cold air coming into California, but all the moisture's still in the jet stream from El Nino, and you get piles of snow. So that's something to consider. But as of right now, looks like we're about at the peak in terms of sea surface temperatures in the Nino 3.4 region. But The jet stream lags behind. There's months worth of energy, we think, in the jet. In fact, here's the GFS model going out. This is the jet stream level model. Here's where we are today. This goes out the full 2 weeks. Yeah, I don't believe a model going out that far, but the models have been incredibly accurate. So this first week, we've seen that already on the Stormsurf models. There goes your jet stream just building strong. Here it comes roaring over the date line. Where are we? We're on Friday night, December 22nd. Look at that, just flat and strong the whole way across the Pacific. There's California. There's the last little bubble on Christmas Day. And then, boom, here comes on the jet on the day after Christmas, plowing into Northern California and digging south, almost down into Southern California as we get into the 28th. And here comes another pulse of wind energy behind that, and you can just see a big old trough setup pushing into the coast, and then more energy in a giant trough behind that. You get the general idea, and here comes more wind. The machine is set. The jet displaced here down at like 32 south. That's in line with point conception. You can just kind of eyeball and look at the moisture plume making the whole way across the southern tier states of the United States. This is exactly what El Nino's promised. This is what we expect is some flavor of this is going to happen. We expect this to probably continue for months as we go through winter. So for now, it looks like El Nino is starting to peak. The jet stream is responding in kind. The storm track looks like it's going to wake up with a significant class storm on the models in, about 5 days out. And looking at the long-term models, we think this is just the beginning of a long run. A little bit concerning, though, is the Southern Oscillation Index values. They just are not responding the way we think they would. For now, I'm writing it off, but maybe 3 months from now, looking back, we'll go, well, maybe we should have paid more attention to that. There's always this little concern. You never get everything you want because, well, this is not a super El Nino. Every El Nino has its own character. This El Nino certainly is a character. It has lots of momentum. It has lots of determination, but it also has its modesty and its stalling nature. And here it comes, and then it doesn't, and this on again, off again sort of thing. And I wouldn't be surprised if that's sort of the case as we go the whole way through winter. There will be periods of intense activity, and then things will back off, and then it'll come again, So it's not going to be a super El Nino where it's just a blast the doors down kind of weather pattern that just doesn't stop. It's going to be sort of on again, off again. So your strategy, I would guess my strategy is going to be when there's waves, I'm going to go get it. Bird in the hand counts. I'm not waiting for the next one. That said, I still think that there is a certain amount of pacing yourself that is going to be required because it's going to be a long 4 to 5 months of surf and snow and all that kind of stuff. High snow levels, though, might rule the day, too, so take that into consideration when you're picking your plans to go skiing and trips and boarding, all that. But I think southern tier states in general will be the call. And surf, for sure, Hawaii, California, and I think at some spots, at some point in time, Southern California, as the storm door is just open and slamming into Northern California, Southern California is going to have its moments of glory as well. And certainly for the folks down in Central America and further south, as the jet stream sinks further south, the storms will push better down into exposed breaks in Central America, and you too will get your share of the fun. So in all, things are looking pretty good, and El Nino is on its way, but looking real long term, we can see the end is in sight as well, but probably not till this winter's over, so not to fret too much. All right, if you enjoyed the video, give us a thumbs up there. If you have questions or concern, write them up. We'll try to reply to them as soon as we can. If you'd like to make a special donation, you're certainly welcome. We appreciate it. Hit the heart with the $sign down below. And other than that, we thank you for your contributions. We thank you for your patience in spending every Sunday watching this for an hour. It's fun to make. I know it's a lot of data. You all are troopers, and we appreciate it. All right, and so with that, we'll do this again next week. Same time, same channel. Thanks for watching.